Assalamualaikum warahmatullahi wabarakatuh. My name is Malaysia. I will continue the presentation for the four pattern of immersed body and boundary layers for the abstract and theory. So for the abstract, in this investigation in the experiment is to know the flow pattern, immersed body and boundary layer, and investigate the flow fluid on the body. This we call as external flow, and the objective in this experiment is to investigate the lift and drag force that was applied on the specimen, and we apply a different angle and different surface area, and we want to observe whether there is a change if we apply a different surface and angle. And we also want to know there is a boundary layer, and are they affected on the rough and smooth surface. On this experiment, we have get the result, which is there is a reaction of flow pattern on the rough and smooth surface with a different angle. Okay, the external flow for the object completely covered with fluid, and there is a fluid force, which is we call as lift and drag. As you can see, this is a winter band tested the flow pattern of the car. This test was used in certain company because this what we call the test is very higher cost to make. So this is wind tunnel, which is we apply a fluid flow of wind, and we want to see the flow of the fluid on the car, and analysis the flow pattern on the car for the performance, to identify the performance of the car. This is commonly used at such as sport car, Formula 1 car. They want to identify the flow pattern of the car for them to increase the performance of the car. This is some of the components that react on the body, which is we have the thrust, the lift, weight, drag. This is also telling us why the aeroplane or aircraft with have the higher weight can fly in the air. These have the in the case of weak study of the lift and drag. As you can see here, there is a specimen of a aerofoil shape, which is there is resultant force, and there is a pressure distribution towards all over the body. There is a higher pressure, the lower pressure of the react on the body, and there also shear stress distribution all over the body, and we can say here there is uh, what the resultant for react on the direction upstream velocity we call is drag, and the resultant normal to the upstream velocity is lift. Okay, here we have the xy component that are this equation. The resultant of the shear stress of pressure distribution can be obtained by the integral of the effect between the two quantities. Okay, you can see there is an angle, there is a shear stress. Okay, and these are the commonly used to find the coefficient lift and the drag coefficient, which is CL is equal to L over the 1 over 2 rho U power of 2 over area. Okay, the CD for the drag coefficient is D over 1 over 2 rho U power of 2 area, and we will get the coefficient of CL, coefficient of lift, and the coefficient of drag. And what is boundary layer? Boundary layer is a thin layer that react on the surface of the body, which is the flow, the fluid flow on towards the body, and there is a laminar boundary and turbulent boundary. Which is laminar, you can see the flow of the fluid is which is the direction of the flow is, you can see it's show the same direction, while the turbulent boundary is have overlap, what we call the direction is not clear. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Nurul Amira binti Muhammad Nasir. MA 19291 is my metric ID. Today I will explain to you about my parts in this lab report. That is chapter 1, Introduction, over title, Flow over Immersed Body and Boundary Layers. Introduction. This theory was introduced by Ludwig Prandtl, a German fluid physicist, in 1905. Okay, this theory is created to understand the flow of slightly viscous near solid boundary. There are three types of flow classification, that is number 1, two-dimensional 2D, number 2 axisymmetric, number 3 three-dimensional, that is 3D. Okay, let's go to drag and lift concept. Drag and lift concept. In this concept, explain that when anybody moves through a fluid, there will be an interaction occur between body and the fluid. Okay, what's mean by drag? Drag means resultant forces in the direction of the upstream velocity, while lift resultant force normal to the upstream velocity. Okay, let's go to drag force. What is drag force? Drag force happens when a fluid flows through an object. The object will experience a resistance force that prevents the object from moving to its direction. Okay, drag force also remains the same whether the body moves through the fluid or the fluid flow around the object, as the relative motion remains the same. Okay. Horizontal force is the drag force, while the vertical force is the lift force, which is perpendicular to the flow of direction. Okay, let's go to next slide. Stagnation pressure. What I mean by stagnation pressure? Stagnation pressure is condition where pressure is bigger compared to zero angle of attack. The pressure below the aerofoil is higher than the pressure above the aerofoil. And in this theory, the flow of a fluid can be in a boundary layer, maybe laminar or turbulent type. Okay, for last slide, I will tell you briefly about some factors affect boundary layer transition. Number one, pressure gradient. Number two, surface roughness. Number three, heat transfer. Number four, body forces. And the last, free stream disturbances. Okay, for the problem statement, we need to first wait for the air bubble to disappear and the water level to stabilize for 10 minutes from the multi-tube manometer. Second, measure the flow rate at different type of surface of the flat plate. And last, for problem statement is calculate the velocity, high pressure, viscosity of fluid near the solid boundary and at symmetric aerofoil at different angle of attack. Okay. For objective, we have to design complete measurement technique for fluid flow and measure the drag and lift forces applied on a symmetrical aerofoil at different angles of attack. Second, to determine the velocity distribution for flat plate. And third, to determine the boundary layer thickness of a flat plate subjected to longitudinal flow for rough and smooth surface. And for scope, we had to use multi-tube manometer and rate on the top portion of the apparatus to take the reading for static height measurement and liquid height. Okay, second, we use pitot tube. Insert and calipers on the right side of flow air bench. After set the value into zero angle to measure the fluid flow velocity at the plate surface. Okay, scope for number 3 to estimate the drag and lift forces at different shapes and angle of attack. I think that's all from me for chapter 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Izzuddin dari Jamiat Malaysia. Method number MPA 19209. For this experiment, I will talk about the theory. In this experiment, we are going to define the result obtained from an experiment regarding flow pattern of the immersed body and boundary layer. This experiment concludes the relationship between the flow velocity and the fluid and its pressure. Okay, firstly, when any shape moves through a fluid, an interaction between the body and the fluid occurs. This effect can be described in terms of the force at the fluid-body interface. This can be described in terms of the stresses wall shear stress due to viscous effect and normal stress due to the pressure. As for flow in a duct, flow in a boundary layer may be laminar or turbulent. Among the factors that affect boundary layer transition are pressure, gradient, surface roughness, heat transfer, body forces, and free stream turbulence. In many real flow situations, a boundary layer develops over a long essential plate surface. Okay, the drag coefficient is a dimensionless quantity that is used to quantify the drag or system of an object in a fluid environment. For the lift coefficient is a number that aerodynamists use to model all of the complex dependencies of shape, inclination, and some flow condition on lift. The lift coefficient Then express the ratio of the lift forces to the forces produced by the dynamic pressure times the area. So this is the formula for drag coefficient. It is the same for the drag coefficient, just the different forces. But the formula is similar. This is for the lift coefficient, and this is how to get the velocity, the pressure, the Reynolds number, and the velocity, the density of the fluid. Alright, that's all from me. Thank you.
Assalamualaikum. My name is Nurul Amira binti Manisir. My metric ID is MA19291. Okay, I will explain about chapter 3, that is methods and procedure that we use in this experiment. Okay, let's go to the next slide. We use method, that is, we use airflow bench to test the internal aerodynamic qualities of engine component and test the intake and exhaust port of cylinder heads of internal combustion engine. Okay. This is our experiment apparatus. Main apparatus is we use airflow bench, and as you can see on the right side, there is number labeled according to the name. That is follow in left side. First, mobile rolling frame, which band top number 2. Next, radio fan 0.55 kilowatt, switchboard and drawer for small port, air intake pipe with throttle valve and thermometer, rectifier, remover nozzle, funnel for air inlet, off air pipe, fixture for 16 full water pressure gauge, and measuring lens for measuring tubes. Next, experiment 1, we conduct 2 experiments. First, we conduct experiment 1, that is a condition where flow pattern of symmetric aerofoil at different angle of attack. Okay. The procedure is this. The experiment setup is as shown in figure below. The aerofoil model is then attached and screwed to the airflow bench. Next, first the experiment start with 0 angle of attack. Then, switch is turned on and the radial fan is allowed to move. The radial fan speed controller is adjusted at any initial speed of 12. The reading are recorded and tabulated. The smoke controller is then pressed to emit smoke into the flow to view the flow of T air on the aerofoil. Next, the picture of the flow is taken. Then radial fan speed controller is then increased by 1 to speed of 19. At last, the experiment is repeated from the step number 5 to step number 8 for 30 and 40 angle. Okay. This is our experiment setup. Experiment for flow pattern for symmetry aerofoil at different angle of attack. We do this at 0 angle, 30 angle and 45 angle. This is the full picture of airflow bench. Okay, next. We have experiment 2 that is conducted for flow over flat plate. Okay, first, the procedure, we have set up the experiment. Second, the smooth surface plate is inserted into the airflow bench. Next, the first distance is taken as 0 and the following distance taken. The pitot tube is connected to the vernier caliper. The pitot tube is first touched to the surface on the flat plate as the first data. Next, the radial fan is then turned on and any data are recorded and tabulated. 7. The distance of the plate is taken from 0 mm, increased by 20 mm to 140 mm, while the pitot tube distance from the surface of flat plate is taken from 4 mm, increased by 4 mm to 32 mm. Then, the experiment is repeated from step number 5 until step number 7 for the rough surface. There are 2 conditions, rough and smooth surface. Okay, as you can see, this is our experimental setup 2. Experiment, flow over flat surface. Okay, I think that's it from me for chapter 3. Thank you.
So hello, good morning. My name is Hani Brenda Duni Anak Winston Raji, MA 19245. First of all, I'm going to present for the result experiment 1, which is the flow patterns of symmetric aerofoil at different angle of attack. So there is 3 angle of attack, which is angle of attack 0 degree, angle of attack 30 degree, and also angle of attack for 45 degree. First of all, we have to calculate for the drag force and the lift force. So, in order to calculate for the drag force, it is said that we have been provided with the CD is equal to 0.59, and the area is C times by L. We'll get 6.3 times 10 to the power of negative 3. So, to get the drag force, the dynamic head is times with area and then times with the CD 0.59 will get us to the drag force value. Meanwhile, for the lift force, it is provided that CL is equal to 0.84, and so repeat the same step and we will get the lift force value. So this is the result for the drag and lift force at various angle of attack for different speed. So we have calculated for the drag force and also the lift force for the angle of attack 0 degree, 30 degree, and also 45 degree. Next, we have plotted the drag and lift force at various angle of attack for different speed. So this is the graph for angle of attack 0 degree, drag force, lift force, and then angle of attack 40 degree, and last is for the 45 degree. Second question is we were asked to sketch the streamlines of the aerofoil at different inclinations angles with separations and stagnation points clearly labeled. So this is the streamlines of the aerofoil at different inclination angles. So next, I'm passing it to my friend Imans to present on the experiment 2. Thank you.
Thank you, Hani, for your presentation. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nur Imam Balkis binti Syamsul Kamar and my matrix number is MA19235. I will continue for results, graph and discussion from Hani Brenda. I will explain about experiment 2, flow over flat plate. This is the data that are provided for us. This data shows for experiment 2A smooth surface flat plate, while this for experiment 2B that represent rough surface flat plate. These are the formula given. To find velocity, we have to square root 2 times pressure dynamic divide density. To find pressure dynamic, density have to times with gravity and times with height. To find Reynolds numbers, density have to times velocity times length and divided dynamic viscosity. The density also are provided. The density equal to 1.184 kg per m3. The dynamic viscosity is equal to 0.000081849 kg per ms. The length is 0.042 m meter, and also the gravity equal to 9.81 m per s square. This is the data that I get from the calculation that I made. For boundary layer thickness, I get it from the data that provided by the lecturer. But for the pressure dynamic, velocity and Reynolds number, I calculate by this formula. There are two questions for experiment 2. For the first question is we need to plot heat, velocity and Reynolds number versus boundary layer for smooth and rough surface at one selected plate distance. Okay, the boundary layer thickness I get from the data that are provided. Velocity, Reynolds number I get from the formula that I calculated, and also the heat I get from the data. I choose at plate distance 60 mm for make it easier for me to plot the graph. This is the graph that I get. At the left vertical are the data for Reynolds number, while at the right vertical are for height and velocity. At the horizontal is the boundary layer. So we can see from this that the higher the Reynolds number, the velocity and the height, the higher the boundary layer. Next, this is for experiment 2B, rough surface, flat place. I will also use the plate distance at 60 millimeter. And the only things that change at here is only the head, H1. The boundary layer thickness, velocity and Reynolds numbers are same. This is the graph for the rough surface. Same as before, at the left vertical is for Reynolds number, at the right vertical is for velocity and height, and at the horizontal is for boundary layers. This graph shows a bit different from the smooth surface, but they are constantly same because the Reynolds number, velocity are increases while the height are decreases. The second question asks us to plot velocity versus distance of plate for smooth and rough surface. I just put the velocity and plate distance into a table. I get it from the velocity I calculate by myself, while plate distance I get from the data. For velocity versus plate distance, we can conclude that the increases of velocity will increase the plate distance. I will pass to Badrul to explain about the conclusion. That's all from me. Thank you.